Alright, welcome to section 8.4, Similarity in Right Triangles. Today we're going to find the geometric mean of given values, and we're going to use geometric means to solve for missing variables. First thing I want you to do is look at this set, or look at these triangles, and we're going to decide what triangles are similar. So I'm going to separate them. So I have the main triangle, and I have one little triangle, and I have two little triangles. So I have these three triangles, and I'm going to decide which ones are congruent. So I'm going to label them like they are up here. So I have A, B, A here, B, D, and this one is DCB, and then this one is A, B, C. Now, I know that this angle and this angle may not be congruent, so I'm just going to assume that they're not. Now, since this is segment BD and this is segment BD, then I know that these two are congruent. Then I also know that these are right angles right here, because that's what they were up here in this picture. Now, A I marked with 1, and angle C I marked with 2. Now, I don't really know anything about angle B. They could be congruent, they could not be congruent. I'm not really sure. So first thing is let's see if this triangle is congruent to the big triangle. So I have ABD is similar to ABC, and I'm going to check to see if this works. Now, ABD, that means I have a one angle with a line congruence. I have a right angle. One of our similarities is angle-angle similarity. Now, do I have a right angle and one line of congruence on this triangle? Hopefully your answer is yes. So I can say that ABD is similar to ABC because of angle-angle similarity. Now, let's look at the next one. Let's look to see if this triangle is congruent to the big triangle. So I have two congruency marks on angle C. I also have two congruency marks on angle C over here. And I have a right angle in this triangle and a right angle in this triangle. So that means that triangle BCD is similar to triangle ACB by angle-angle similarity as well. Now, I forgot to put triangle here and triangle here because we are talking about triangles. And the last one, we're going to see if these two angles are similar. So, when I'm looking at these, I have a right angle in both of them. I'm not so sure that these angles are congruent, and I'm also not so sure that these angles are congruent. So I know about a side and an angle, which means I would need to know more information in order to prove that these two are similar. One may be bigger than the other, but I'm not sure about angles. Okay, what we're learning today is geometric mean. It's when the means are the same. So what we're going to do is have a model that looks like this. We have A over X equals X over B. Now, when I have something like this, I'm going to cross multiply. So I end up with X times X, which is X squared, is equal to A times B. Now, I can square root both sides to solve for X. So I have X is equal to the square root of AB. Now, it does not matter which number is A and which number is B as long as I set it up with A over X equals X over B. So, looking at our first example, it says find the geometric mean of 15 and 20. So I have A over X is equal to X over B. Now, it doesn't matter, I can say this one's A and this one's B, or this one's B and this one's A. I'm just going to keep them in order and say A and B. So I have 15 over X is equal to X over 20, And then now I'm going to cross multiply. So I have x squared is equal to 300. Now I can do the square root of both sides. So I have x is equal to the square root of 300. Now I'm not going to leave it like this because the square root of 300 can be reduced. So I have x is equal to square root 300. Now I can do my factor tree. So I have 30 and 10. Then 30 goes to 15 and 2. 10 goes to 2 and 5. So I have, oh, and 15 goes to 5 and 3. So I have a group of 2's. They can come out front. So now I have x is equal to 2 times, and then I also have a group of 5's. So 5's can also come out front. And then square root of my leftovers, which is my 3. So my answer is x equals 10 radical 3. Now the next one. The next one, it says find the geometric mean of 3 and 12. So I'm going to say a over x is equal to x over b. I'm going to label this one as a and this one as b. So I have 3 over x is equal to x over 12. Then I'm going to cross multiply. Oops. I'm going to cross multiply. So I have 3 times 12 and x times x. So 3 times 12 is 36 is equal to x squared. Now I'm going to square root both sides. The square root of 36 is 6. And the square root of x squared is x. So you're left with x is equal to 6. Now we're going to move on and use this stuff for triangles. Specifically right triangles. So first thing I'm going to do is I'm going to split this up into separate triangles so that my brain doesn't get confused. So I have a triangle here like this, and this is 2 and 6, and this is my ACD triangle. So that's here. So that's my green triangle. And then I'm going to have my blue triangle, which is going to be this one. So I'm going to have here, like this, and this is x and y and 6. Now this is a right angle here, and we also know that this one is a right angle here. So now we are going to use a proportion, and we're going to use this with right triangles. So I'm going to set up my proportion to look like this. We're going to have leg, and it's going to be the small leg, divided by the altitude, or the height, is equal to altitude over leg small. Now this is going to be the first triangle, so first triangle, and this is the second triangle. Now look and notice that I have the same value in these two positions. Like when I had a over x equals x over b, I have across are the same value. So if I'm looking at my small triangle or my first triangle, then I have my small leg, which is 2. So I have 2 divided by my altitude, or my height is going to be 6, is equal to my altitude of this triangle, which is also 6, divided by my small leg, which is going to be x. So now I have to cross multiply. So I have 2x is equal to 36. So my x is equal to 18. So right here is 18, and right here is 18. Now I can do one of two things. I can either use Pythagorean theorem to solve for y, which is probably your best bet, or I could set up another proportion. I would prefer to set up the Pythagorean theorem because I'm really good at that. So let's look at the next one. Alright, so I'm going to be solving for x and y. Now I'm going to, instead of splitting this time, I'm just going to highlight our different pieces. So my long leg on this on this triangle here is 12. So this is my long leg for this triangle. My long leg for this right triangle is this line here. And then I'm also going to mark my short legs. So this is my short leg for my little triangle, and this is going to be my short leg for my big triangle. So now I'm going to set up a proportion. So I'm going to say long over short equals long over short, because I need to figure out y. So I have my long leg of my big triangle. We'll do big triangle, small triangle. So I have my long leg of my big triangle, which we highlighted in yellow, which is 12, divided by my short leg, which is y. So that is equal to my small triangle, and my long leg is y, divided by my short leg, which is 4. Now I can cross multiply, and notice how this looks just like geometric mean. We have a over y equals y over x. So I'm going to cross multiply. So I have 48 is equal to y squared. So I have the square root of both sides. Now I am going to simplify this. So this will go to 6 and 8. Then 2 and 3. This will go to 4 and 2, and 2 and 2. So I'm looking for pairs, so I have a pair here. I also have a pair here. And I have a 3 left over that doesn't have a pair. So my y is going to equal 2 times 2, because that's what's the number that's circled, square root 3. So y is equal to 4 radical 3. So right here is 4 radical 3. Now, in order to solve for x, I can use Pythagorean theorem. So I'm going to say my hypotenuse is my c squared, so this is my c squared. So I have 4 radical 3 squared plus 4 squared, which is equal to x squared. Now, 4 radical 3 squared is going to be 16 radical 3 plus 16 is equal to x squared, or this is radical 3 squared. And the square root of a squared thing is 16 times 3 plus 16 is equal to x squared. So I have 16 times 3, which is 48. So I have 48 plus 16 equals x squared. 48 plus 16 is 64. So then I have 64 is equal to x squared, and square root both sides. So then I have 8 is equal to x. So this value here is 8. Now, I want you to try to do this one on your own. If you need to go back and watch one of the examples that I did above, that's fine. I will see you later.